would like to give you again. So my disclosure regarding those companies, all of them are working in the laser field. Again, you know that we are using thulium and holmium element coming from Sweden originally, due to the names. You also know that laser means light. I think it's all the time very important to remind that. People sometimes forget laser is super efficient to treat stones, but it's also light, so it can burn. And I think that in the last 10-15 years, most of us, we forget about that. And this is probably the reason we experience actually so many problems regarding thermal damage. You know that the first pulsed laser with this concept of MOSIS, it was described in 1989, this bubble, these pulses. And since it's a pulsed laser and not continuous laser, we need to consider this very basic formula, and we cannot go over from this formula. I can just tell you that 25 years ago, when I really started to use holmium laser at that time, I didn't know almost nothing regarding laser technology, and I met a French guy. He was an engineer in optics, and he was all the time talking to me regarding this setting, talking about energy and power. And all the time I was telling this guy, no, it's energy and frequency. And he said, no, it's energy and total power. At that time, I didn't really understand why he was focusing on energy and power and not frequency, because at the end it's the same. But I will tell you at the end. The second point, he also told me he was very, very concerned that urologists will start to use laser because he said, you will have problems. And I say, what? We are not so stupid. We did we went to the university, we can understand, there's no reason. But he said, no, because laser is very powerful and could be very, very dangerous, and you will have problem. At that time, I was thinking, okay, let's see. But I think that looking at what this guy told me, he was right, totally right, on the two aspects. So today we have different laser technology, holmium YAG, thulium YAG, TFL, you know that. Question is, which is the best? Very classical question from the colleagues. I would like to buy one laser due to the budget. Which one? And we have no right answer. The good question, the following question is, what would you like to do with laser? Because if you are looking for one single laser with the best to do everything, it doesn't exist. All of them are okay. You can do more or less everything, but maybe you will not be in the best situation if we are talking about dusting, if you are using holmium, for example. But if you are more looking for a fragmentation because you do more and more PCNL and not so many flexible ureteroscopy, probably holmium is the best for you. And then it depends also if you do prostate. Which technique do you like? So very complicated, to be honest, to answer this question. The best situation is when you have everything, of course. So you know holmium, 1992, first use of holmium. That's the initial report from Johnson. I love this report. If you go back to this publication, you will see that most of the messages that we are giving today are already described in this publication. And at that time, Johnson, he was using a very low power system, 15 watts, 10 possible settings, very simple. But even using this simple machine, he described what we are doing today. What you need to remind in terms of settings, definitions. This is energy, that's pulse duration, this is peak power. It's not exactly like a line at the beginning, but that's an overshoot at the beginning of the pulse. And then you can modulate some of these parameters. The first, you can use high energy. What does it mean, high energy? Nobody knows. We have no clear definition of high energy. Let's say more than 1 joule. Okay, but it's not something well established. If you set the laser at the same time, so high energy, more than 1, 1.2, 1.5, we are never using more than 2 joules, 2 Treadstones. At the same time, you set the laser with a short pulse. What does it mean? It means the system will calculate by itself according to the energy and the frequency, so the power that you select. The system will optimize to reduce the pulse at the max. It doesn't mean that the pulse is super short. The system will optimize, do the best to have the pulse as short as possible. But if you have this kind of combination, what do you produce? High peak power, you have an overshoot of power at the beginning, and you create fragmentation. This is the definition of fragmentation. High energy, short pulse. On the opposite, and it's especially true for holmium, of course, if you use low energy, again, no clear definition. What is low energy? 0.2, 0.3, 0.4, nobody knows. But let's say something less than 0.5. So low energy, at the same time long pulse, it's exactly the same mechanism. The system will optimize according to the power you are using with this energy. But if you combine like that, you decrease a lot the peak power, so you have less retropulsion, you will damage much less the laser fiber, and then you create dusting. This is dusting. You create a small pieces, a small particle, 1 pulse, 1 particle, very small. That's what we call dust. We are not talking, we are not explaining regarding frequency. Dusting is not high frequency. Dusting, this is this. So what is the role of frequency? You reproduce the combination. You do it slowly, what we call low frequency, or you do it very fast, quickly, with many pulses per second, what we call high frequency. So if you do this, what is the difference at the end? At the end, it's the speed. With more frequency, you have more pulses, you are supposed to be more efficient. In the lab, it's true. You go much faster in the lab. Problem is in the real life. Can you be sure that because you set 20, 40 hertz, that all the pulses are on the stone? Because when you activate the laser, if only few pulses reach the stone and the rest cannot, there's no reason. You will not be more efficient. So it's very dependent of you technique. Are you able to put all the pulses on the stone? That's the main question. To be honest, we are not. I have a huge experience. Personally, if I can control 10, 15 hertz in the best way, I'm very happy. So 40 hertz, absolutely not possible in my hands. Presetting. So according to that, you know, the companies, they went to the lab and they produced some recommendation, preset. But the presetting are coming from lab experiment. And if you look in between the different laser company, no consensus. What does it mean? It means that there's no clear fixed settings. It's impossible. We can give some range in terms of energy, power, so frequency, but we cannot tell the people dusting is 0.620. No, it depends again of you. So very complicated. Again, we can give some starting point, some range, and each of us, we need to find the settings that we like, that we are able to manage. What is the difference between low and high power? Just frequency, much more frequency. Okay, to do what? In the lab, to go much faster. But in the real life, who is able to control this super high frequency? Nobody. Nobody can. But if you increase the frequency, you increase the power. And then you become very dangerous in terms of thermal damage. So we need to, again, to accept that and to stop to promote a high frequency regime, which is definitively not a good recommendation, but very dangerous. And we have publications now. performing flexible ureteroscopy. We have many publications actually to demonstrate that even you are using low or high power, so it means low or high frequency, you do exactly the same job. There's no difference. Second point is when some people are telling you, yes, but when I use high frequency, I'm going a little bit faster. The question is, okay, but when do you decide to stop? According to the size of the fragments. And you said, this is dust. Maybe for another colleague, he will say, it's not dust. For me, it's still tiny fragments. I need to proceed. And then the time will be longer. So very complicated actually to evaluate that. 2018, the super pulse thulium fiber, and you know everything regarding this thulium fiber. The beauty of this one is the shape of the pulse. It's very constant, very square, low peak power. That's the reason why the physician, the physicist, they call it the super pulse, compared to the thulium fiber, which is completely unstable. Presetting, exactly the same. We cannot give you exact presetting. Main differences between holmium and thulium fiber. One of the main benefits, and that's why we love thulium fiber, possibility to use tiny surgical fiber that you connect. Actually 150 micron, very soon 95 micron, meaning that if you decrease the surface, the cross section of the fiber, you produce smaller pieces. And that's one of the reasons to produce tiny pieces. If you compare the regular holmium 270, 150, the surface decreased by 3.3. So the reason you produce much smaller pieces. In terms of other difference, pulse energy, it's possible to have very low energy, but we don't really use it because it's not efficient in the real life. Peak power, very low. So that's why dusting is so good, and less retropulsion. Possibility to have super high frequency, yes, to go super fast in the lab, but in the real life, we don't use it, okay? So it's not really a benefit at the end. Look at that in the lab, maximum frequency with holmium, thulium. It's beautiful to look, to see, to impress the people, but no need to use that because nobody can, okay? So to do what? In terms of lab experiment, thulium fiber is superior in many aspects. It goes faster, finer, you don't damage the fiber. So in the lab, thulium fiber is fantastic. In the real life, we have this excellent publication from the Nordic colleague, Dr. Olivier. He said that it was better. American colleagues said, no, it's exactly the same. So some controversies. Thulium fiber, thulium YAG is not thulium fiber. It's different technology using thulium elements, but completely different. Thulium YAG, we don't have so much data actually. What we can say to summarize, it's a bit in between holmium and in between thulium fiber. So it means it's better than thulium fiber for the fragmentation, but probably not so good than thulium fiber for the dusting. So it's something in between. Again, a great technology. The problem is what? The problem is this one, ureteral stenosis. You know that we have more and more cases like that. And it's not because we have an epidemic of impacted ureteral stone, okay? We still have, we are all okay, but we have more stenosis because of laser, because we are not using laser in good condition. It was also demonstrated, it's very clear now, that into the ureter, high frequency is super dangerous because you cannot control all the pulses. Some of them are going away from the stone, and away from the stone means what? It means mucosa. You touch directly the mucosa. That's this problem. If you increase the total power, since you have more power, more joules means more calorie, you heat the fluid and hot water burns, okay? Whatever the laser you use, don't think that thulium fiber is more dangerous than holmium. It's wrong. We need to stop with this message. Exactly the same for all type of laser. And that's probably the explanation for this case report regarding pseudoaneurysm. It looks amazing to produce pseudoaneurysm performing flexible ureteroscopy. We have case report. And not only with thulium, we have more case report with holmium actually on that. You can have a look. And if you look at the parameter, look, high power. And high power because of what? Because of high frequency, not because of high energy. So if we respect less than 20 watts, we are not supposed to have any problem. Second problem, when you have high power, that's because you have high frequency. It's not possible to have high power with high energy, not today. But today it's like this. So if you have too much frequency, pulse away. Now it's a direct damage. There's no need to have high frequency. One pulse touching the mucosa, you damage. So if you damage multiple times per second, at the end, it's not small, it's a big damage, okay, to generate. So two problems. This thermal damage because of the hot water and because of direct touching of the mucosa. Again, it's demonstrated. We have a lot of publications actually to confirm high frequency, super dangerous. That's why today we recommend what? We recommend super low frequency, less than 10. Personally, I always start with 5 Hertz to be sure I control everything on the stone, not on the mucosa. And the power, of course, since you reduce the frequency, the power less than 10 watts together. We also know that the continuous activation of the laser compared to the burst, for the same total power, continuous is safer because you distribute regularly the pulses so you can control them, okay, compared to the burst. Also, a great publication, again from Ulvik and from Ventimiglia, from Milano, to demonstrate what? There's some limit. If you respect less than 20 watts, less than 10 in the ureter, you are not supposed to have thermal damage, okay? But remember, into the ureter, we need also to have low frequency at the same time. It's not only low power. What do we have to help us in the future? We have this kind of technology. This one is from IPG, what we call the stone sense. It's an automatic control by the laser if the fiber is in front of the stone or in front of the tissue. You teach at the beginning of the procedure, you tell the laser, this is the tissue, the system learns, and then when you activate, it recognizes the tissue, stop the laser automatically, it stops 40 times faster than human reaction. So this kind of system are coming, and it will help a lot. So the question is, which laser do you prefer? You can talk about that, and you will have many, many debates. My question is more, which driver are you? It depends much more about what you are doing and if you are able to control this kind of powerful car. So, to conclude, less than 20 watts, into the ureter, less than 10 and low frequency. And if you would like to join us to the ICE meeting in Valencia in October, we will be more than happy. Thank you.